Example 4, still tackling it the same way. Start out by seeing that square, and it's affiliated with a variable, so I know that this is going to be dealing with a quadratic original function. When we have it squared like this, what I can identify is that my vertex was at -2 and 0, which means it's on the x-axis. It's also opening upwards, technically. We don't have any negatives out in front of that. So when I go to sketch my graph, it looks like this. And I've only got one intercept on my x-axis, which means I'm only going to have, hope you thought it, hope you completed that sentence, one vertical asymptote. Again, I can solve for it though, if I'm not sure. So I've got my NPVs are going to be at x plus 2 squared equals 0, cannot be 0. I take the square root first because it is outside of the brackets, peeling it away to get at the guts. Square root of 0 is 0, so that keeps things nice and simple. So x cannot be -2, which is what I saw up here as well. From there, table of values, get some numbers. So I'm going to go on either side of my vertical asymptote, so -4, -3, -1, and 0. And I plug them in. So -4 plus 2 is -2 squared is 4. So that's 1/4. Don't forget that it's 1 over this function. -3 plus 2 is 1 squared is just 1. Okay, -1 plus 2 is +1 squared, or 1. That is invariant. And 0 plus 2 is 2 squared is 4, so 1/4. So again, now we're getting that total symmetry even within the signs. So when I go to graph this, I'm only in the positive section, so I'm going to put my x-axis lower down. I'm also going to put my y-axis towards the right because I'm dealing with mostly negative x values. From there, I'm going to kind of stack up my y values. I only need to go to 1 in terms of actual defined points that I have. So I am going to spread this out a lot, and I'm going to actually go up 1, 2, 3, 4, 5, 6, 7. I'm going to say that that is +1, so up by tenths. Horizontally, I'll just go up by half still. So -1, -2, -3, -4, -5, and +1, 2. Okay, so I've got my scale defined. I've got some points. I'm going to use that red pen again to put in my vertical asymptote here now that I have one, unlike the previous example. Remembering to name that vertical asymptote by what value it is. And I'm going to put in that horizontal asymptote where I know it is as well, which is y equals 0. From here, put my points on the graph, which is here and here. There we go. Again, you can figure out some more points now that we know kind of what my scale is. If I wanted to figure out what like -5 would give me, I'd go -5 plus 2 is 3, -3 squared is 9. So I'm looking at a 9th, which would be just above here. So I can start filling those in. You could continue to solve for values. What I'm going to do is I'm just going to start drawing my curve at this point. There we go. Now I'm approaching my asymptote. That was not so good. So figure out how you can draw your curve as best you can without making it too wobbly and going through your points. Okay, so there's my graph. Same thing. Domain, range, vertical asymptotes, horizontal asymptote. Vertical asymptotes at x equals -2. Horizontal asymptote at y equals 0. And so writing my domain, I'm going to do set notation this time, just so again we're getting some practice seeing both. X can be anything, but it cannot be -2. Range is going to be a little bit different because it actually has some variation. It doesn't go negative at all. It doesn't pick up on the other side of that horizontal asymptote. So what I'm going to say is y can be absolutely anything. That's true, but y is always greater than 0. And it's not equal to 0 because of that horizontal asymptote. Okay, and so I varied this in comparison to my notation with asymptotes previously because it's not below.